Alright, today we're going to talk about simplifying radicals. The objective is I will learn to simplify radical expressions. Alright, a radical expression is anything that has this symbol on it. Now it can have things outside or on the inside, so you could have something like 3x square root of 4x to the 5th power. That is still a radical, and we're going to talk about how to simplify this. Right? And then there's kind of three things that you can use to see if you've gotten this in lowest terms. Alright, so radicals are simplified if the following statements are all true. There are no fractions under the radical, there are no radicals in the denominator, and there are no perfect square factors under the denominator. So we'll look at some of those examples and we'll go through those step by step. Alright, this first example I'm going to do it two ways. One, the easier way that I prefer to do it, and then one that is a little more involved. There's more steps to it. Right, so this thing right here, you want to look for perfect squares. So I'm going to break this down into two factors where one of them is a perfect square. So this one I'm going to factor into 16 times 3. And then I can break this apart into the square root of 16 times the square root of 3. 16 is a perfect square, so then I would just do the square root of 16 is 4. And this 3 is prime, so that stays in the radical, so that would be 4 square roots of 3. Right? And now we'd go back. These are no fractions in the radical. I don't have any fractions. There's no radicals in the denominator. That doesn't apply because there's no fractions. And there's no perfect squares in the denominator. Again, 3 is prime, so this would be my answer, 4 square roots of 3. Now, if you don't remember what a perfect square is, that's these things. We'll pull up the multiplication table. And that's anything times itself. So 1 times 1, 2 times 2, etc. all the way down. Say like 12 times 12 would be 144. These are all perfect squares. Now for this, it might be useful or faster for you guys to find something like this, which is a square and square root table. Now this pulls up all the perfect squares. So this will help you factor much faster. Alright, so now we're going to do this the more involved method where there's multiple steps, and that just depends on your multiplication skills. So what I'm going to do is I'm going to break down 48 by whatever factors I can come up with. Not necessarily the perfect squares, but if you want, you can start with 2. And that would be 48. It would be 2 times 24. Alright, 2 is prime, so I'm going to go ahead and kind of circle that. Then I'm going to factor 24. I want to break that down again. You can use any factors you want, but I'm going to do this using kind of the long method just to make things simpler. So that would be 2 times 12. 2 is prime. Factor down 12 into 2 times 6. Then I'm going to factor down 6 into 2 times 3. Okay, so these that I circled are all my primes. This would be prime factorization. So the square root of 48 would be equal to the square root of 2 times 2 times 2 times 2 times 3. Right, and then in order to come outside of the square root, you have to have pairs. So this would be one pair of 2's, and this would be another pair of 2's. So that pair would come out, and that pair would come out. So you'd have 2 times 2, and the 3 would stay inside. Okay, and then you would just multiply whatever comes out, you'd multiply that together, so that would be 4 square roots of 3, which is what we got here. Again, so this to me is quicker if you can figure out the perfect squares. If you want to do prime factorization, that will also work. You just might have to do a little more factoring. Alright, so next I want you to try example 2 on your own, square root of 56. So pause the video and then come back with me and check your answer. Alright, did you pause the video? Well, lucky for you, I'm not going to show you the answer to this one. This is one of the ones I expect to see on your notes. So this is what I'm going to be looking for and checking to make sure you did this right. And then we'll go on from there. So this one's for you. Alright, next I'm going to show you one where there is a number already outside the square root, and we're going to factor this. So again, I'm going to break down this 18 into two factors. In this case, 9 times 2. Remember, 9 is a perfect square. So then that's going to be 2 times the square root of 9 times the square root of 2. Which, if I factor this out, this is times here as well. So this is going to be 2 times 3 square roots of 2. Okay. And then 2 times 3 would be 6 square roots of 2. Alright, 2's prime, so I know that I'm done. Alright, next example 4. Now we get into the fractions, where there's fractions in here. Okay. Kind of like this, where I can break it up into square root of 9 times the square root of 2. I can separate this into the square root of 3 over the square root of 8. Okay, but I can't have a square root in the denominator, so I'm going to have to break this down and factor it out. Alright, so let's see, factoring this out, I'm going to have square root of 3 on top as my numerator, and I'll break this up into the square root of 4 times the square root of 2, because the 4 times 2 would give me 8. Again, 4 is a perfect square, so this would come out to the square root of 3 over 2 square roots of 2. Alright, but we still have this square root in the denominator. So to fix that, or to kind of get rid of this radical in the denominator, I'm going to multiply by the square root of 2 times the square root of 2. And now when I do that, what happens is I have 2 times the square root of 2 times the square root of 2 in the denominator. And I have the square root of 3 times the square root of 2 in the numerator. Okay, but if I combine this, it's the same thing as writing 2 square root of 2 times 2, right, which gives me a pair. So this is going to come out of the denominator. And so what I end up having is we have the square root of 3 times the square root of 2. Okay, then we have the 2 that was already on the outside, and then times the pair of 2 that came out. And I end up getting square root of 6 over 4. Okay. Now we have no more radicals in the denominator. The only radical we have is square root of 6. But if we factor that, that's the 3 and the 2, and both of those are prime. That's not going to create any pairs. So that tells me I'm done. And this is my answer. Square root of 6 over 4. Alright, now example 5 is another one that I want you to do on your own. I'm going to be checking that on your notes, so I expect to see square root of 6 over the square root of 5. I expect this to be written in simplest radical form. So I'm going to leave that one for you. I'm going to move up down to, to number 6, example 6, and we're going to introduce some exponents. There's not exponents, some variables into this. But not to worry, because I can rewrite this as 24 times x times x times x. Alright, so the exponent part, that's actually the easy part because I'm looking at pairs. So now I'm going to have a pair of x that comes out, and then there's going to be one x that's left over. So the 24 is kind of what we've been doing. We can factor this out into 4 times 6. This is going to be 2 times 2. This would be 2 times 3. So these are my pairs, or my primes, excuse me. Okay, so I'm going to have one pair of 2's and a pair of x's. So this is going to be 2x square root of 2 times 3 times x. These were the terms that did not have pairs in them or with them, so those have to stay inside the square root. Okay, and then kind of simplifying all of that, combining, multiplying this out, the answer is 2x square root of 6x. Right? So that would be your answer. That's in simplest form. Alright, and the last example I'm going to show you is I'm going to show you a fraction inside the radical with variables in the problem. Again, this is going to be not as bad as it looks because we have x's on the numerator and x's in the denominator. If I have 3 on the bottom and 4 on top, I mean, I can factor out 3 on each, and that's just going to leave me 1 x in the numerator. Y to the third power, there's no y's in the denominator, so that's going to stay. Now the 10 and 5, that's going to factor out as well. So I can factor out a 5, that's going to leave me 1 there. If I factor out 5, 10 divided by 5, that's going to give me 2. So it's always a great idea to simplify as much as you can before you start pairing things out and looking for perfect squares. So rewriting this, after I factor it, I'm going to have 3 times the square root of 2x y to the third. Now in the denominator, all of that disappeared because we were able to factor out the 5. We got all 3 x's factored out from the numerator. So really there's just a 1 right here, which means it's not necessary. I don't need that. Okay, so then the only thing that's left is this y cubed. Well, remember that y cubed is really y times y times y. So that does give me one pair of y's that's going to come out and one y that stays. So the answer is 3y for this y, pair of y's that came out. Right, 2's prime, so that's got to stay. X to the first power, there's only one x left. And this y cubed, there's one y that's left in there. So in simplest form, the answer is 3y square root of 2xy.